Here we're being told that the graph of a twice differentiable function y equals f of x is concave up on this interval here and is tangent to the line y equals 5x minus 3 at x equals 2. X equals 2 is conveniently right in the middle of that interval right there. And then based upon that information, they want to know which of the following statements must be true. Not which could be true, but which ones must be absolutely true about the derivative of f. Well, let's see what we can figure out about this. The first thing we know is that this graph is concave up. And so when I go to do that, I'm going to say to myself, all right, I've got two halves of a concave up shape. I've got the left half and the right half here. So I've some people like to interpret concave up as meaning it's the full shape, so it would be that full smiley face. Really, concave up could be either half of this. And so on this left half, this is what you would be calling the decreasing portion of a concave up shape. And this side over here would be the increasing portion of the concave up shape. So how do we determine if we have either one of those halves? Well, that is where our tangent line comes into play. Tangent lines. What do we know about a tangent line? Well, the derivative at a point, at some value, is the slope of the tangent line. And so that's the key here, is understanding that the derivative at a point is the slope of the tangent line. So our derivative at x equals 2 specifically, that our derivative, our slope of that tangent line is 5, right? We've got a y equals mx plus b going on up there. So we know the derivative in this situation is 5. What does that tell us? Well, that tells us that we have a positive derivative, and a positive derivative tells us that our graph is increasing and heading up. So when we come over here, we know that what we're looking at is this half of a concave up shape. And if I kind of mark where that would be, that f 5x minus 3, it doesn't have to be accurate, but just to give myself a sense of where that would be, that would be the graph right there. Let's call that 5x minus 3. And so I know the slope of that graph, the derivative value there has to be 5. Well, then what do I know about slopes happening before and after it? Because that's really what they're being asked about, right? They want to know what's going on with the derivative of f. They want to know what is happening to the slope of f along that same interval right there. And if you look at this, you just have to remind yourself of how this shape is going. So if I'm down here and I have a slope at that point, that slope there is flatter than the slope at my blue mark, the mark I'm looking at. And so what I know is that value would be smaller. So if that blue line is happening at 5, then maybe this purple line here would be a smaller one that's happening at 1. And I know that any place after that this would be steeper, that my tangent line would be much steeper beyond that blue point. So if that was 5 there, maybe we say that this is an m of 10. So what I'm reading off of here is that I know not exactly what my slopes are at those points, but I know any slope that's happening before that blue point right there, those slopes are all going to be smaller than that first slope, than my slope at the blue. And I know that any slopes that are happening after that right there, that those slopes are all going to be larger. They're going to be steeper slopes. And so as I look through here, that's what these things are saying. So the derivative is greater than or equal to 5, which means it's steeper. When it is where? That's the key on these, right? So 1.9 to 2, that's going to be back here. This is happening at 2. And so the section that's before that, before 2, that would be the section that we said had to be smaller or flatter, and that's not what's going on there, so that's not the right answer. The derivative is less than 0 on the interval. Well, the derivative is less than 0 is telling us that this would be decreasing along that interval. Well, we know that this graph has to have the same shape. It's not changing concavity, and they told us it's concave up. And we saw that our decreasing section would have had to have been over here, so that can't be true. Not must be true. I mean, there's a lot of things that could happen, but that's definitely not what must happen. Then as we go to the next one, it's saying to us, okay, the derivative of f prime is less than 5. It's flatter. It's smaller. And where is it smaller? Where is it telling us? You always got to check that. It's telling us 1.9 to 2. That's before. So if we look, that's what we're talking about right here, that this section is going to have a smaller graph, a smaller slope, excuse me, so because it's flatter. It's the earlier part of that increasing concave up section. So that actually is going to probably be our answer right there. And then the next one is telling us that the graph is positive, it's increasing from 1.9 to 2.1. And again, like, we know that one section of it was increasing, but we don't know exactly where and when this whole thing begins. So we can't say with 100% certainty that that's absolutely true. The graph could have been doing, again, these graphs can do some funky stuff. Like at 1.9 or at 2 right there, it could have switched over and been going up this way. It's not a guarantee. And then we definitely know that the derivative is not a constant, because that would have had a slope of 0. So what we're looking at here is our derivative is smaller than 5. That is what we're 100% must be true because it's before that point. So just keep in mind when you're doing these, this is really, they love to do this little game where you've got your two sides of either a concave up or a concave down, and they tell you about some point along here. And just remember that if that has a slope of 5, that anything beyond that would have to be steeper. That would have to have a slope of 10. It has to have that. Anything before that would have to have a smaller slope. It has to have a slope. You don't know what the slope is, but you know that it would have to be a smaller slope because it would have to be flatter along that concave up section coming through there. And so that's the one thing we're guaranteed, is that we're for sure going to have a slope that is flatter, a slope that is less than our original slope, less than 5. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.